Hey, Sophia likes math and history, and we are gonna look at measuring the lines and the angles. So in geometry, not only we're trying to find this angle or that angle, or trying to solve for x, or proving that triangle ABC whatsoever, but we also have to measure the lines and the angles. We would do a lot of measuring in geometry, and since there are shapes around us in the real world, we'll have to measure those too. So when you probably learned about measurements, you probably learned how to measure lines on a number line or on a ruler. For example, this scenario, segment AB is 1, 2, 3, 4, 5, 6, 7, 8 units long. But sometimes geometry will ask you what happens if there's a middle point and where would that middle point be? Well, the middle point would be right around here, near 3. We're gonna call that point Y. So there is one example where we have to measure a line. But there are more angles than lines. But angles are something that we're going to look at too. But there's more information on that. What we just did is we just measured a line. Simply and easy. So yeah, check. Now off to angles. Okay, so here is an angle. An angle is made up of two rays or two lines that have a common endpoint. That endpoint can also be called the vertex. We are not trying to figure out how long the two lines are like the previous one. What we're trying to do is we're trying to find out how wide it is. So from here all the way to here. But instead of calling it units, or instead of calling it like inches, centimeters, millimeters, whatsoever, we are going to try to find the degrees of it by using a tool called a protractor. So to understand what the measurements of a protractor are, angles are measured in degrees. So we're going to put the protractor right on the vertex. And we're also going to put the bottom line on that bottom line. So right here, it says that it's around 40 degrees to, I'm going to say 36 to 40 degrees. So that is how wide this angle is. Basically, it's that wide. 36 to 40 degrees. So that is how you measure by using a protractor, but angles have names too, and they also have identifications. Lines are just called lines, but what is this angle called? If we said that it was 40 degrees wide, what do you think this angle is called? Type in the comments below. Well, since this is 40 degrees, and if you look at a protractor, 90 degrees would mean a perfect right angle. So if there's an angle that's smaller than a right angle, this is called an acute angle. An acute angle is an angle that looks like this, and its degree by measure is less than 90 degrees. It's acute because it's very cute. So here's an example of an acute angle, smaller than 90-degree angles.
Well, I am not gonna be eliminated. I've got my mirror. Ha!
Why is there a bush here?
It's so bright!
Yeah! here again.
That was an example of an acute angle because the laser was hitting the mirror and it made an angle less than 90 degrees. That video was made by Jack NF Jellify. You should really subscribe to his channel because he makes a video series called Dream Island. So, moving on. If we have an angle that is less than 90 degrees, what happens if we have this kind of angle? So this kind of angle looks a little bit wider than the last one. Let's use the protractor and see what happens. So it appears that it says it's around 120 degrees. So how wide it is in degrees is going to be 120. Say, if we said an acute angle was less than 90 degrees and 120 degrees is greater than 90 degrees, therefore this is called an obtuse angle. Obtuse. That means the angle is very, very wide, and it also means that its measurement in degrees using a protractor is a lot more than 90 degrees. So here is an example of an obtuse angle. That can be an example of an obtuse angle because the book had pages in it that squeeze the characters flat. Moving on. So if we have an angle that's larger than 90 degrees, and if we have one that is smaller than 90 degrees, then what happens if we have this? So this angle seems a little bit strange. It is an angle, but it's not as wide as this one, but it's wider than this one. So if we have an angle that's more than 90 degrees, and one that's less than 90 degrees, then you want to guess what this one is? Using the protractor, it's exactly 90 degrees. Therefore, it is going to be 90 degrees, and it's called a right triangle. No, a right angle. There is no triangle, but you work a lot with right angles in triangles, like the Pythagorean theorem. This one kind of gives it away because a square has 90-degree angles that are right here. And the square is a big giveaway, indicating that this is a perfect right angle. If you have an angle like 88.999999 repeating, it's not a right angle. It has to be exactly 90 degrees. If it's anything like this, or anything a lot bigger, like 90.000001, then it would be this one or this one. So it has to be perfectly 90 degrees. If it's 90 degrees and it's a square, you can be assured that this is rightly a right angle. So here is an example of a right angle. A Minecraft chest can be an example of a right angle because it opens and closes like one. So, this last angle we're going to look at doesn't look like an angle, but it is still an angle because there are two lines, or two segments, or two rays that have a common endpoint, or a vertex. Here is what it looks like. So this one is still an angle. Let's use the protractor. So, it appears that from here, it goes at 180 degrees. In that case, if it's 180 degrees, it means that this is called a straight angle, or a straight line. Well, it doesn't look like an angle, so we'll just call it a straight line. Straight lines are 180 degrees. They're not obtuse angles, because an obtuse angle can range from anything greater than 90 degrees, but has to be less than 180. If it's exactly 180, then it's this. So here's an example of a straight line. Lines that have two rays, two lines that have a common vertex or endpoint.
Take flight! Stardust Dragon! I activate my monsters effect!
So, summoning the dragon in Yu-Gi-Oh! Can be an example, because the light makes a straight line. And those are all the measurements that we need to learn for this video. We have measured lines, angles like acute, obtuse, right, and straight lines. I hope this video has helped you understand lines and the angles as measurements, or measuring them. Thank you for watching Talpinga Math Industry. Like and subscribe!